Next, we're looking at capacitors connected in parallel. So you guys remember the parallel connection, say a resistor and a second resistor. So in parallel connection, what happens? They have two nodes that is common, one. So then we can talk about different set of current flowing through the resistors. And one main thing that we can talk about is voltage. The voltage between them will be the same. Here too we'll have capacitors connected in parallel in the similar manner. In terms of node and everything, it's the same, and it also the voltage drop will also be the same. So two capacitors are said to be in parallel when both of their terminals are connected to the corresponding terminal of another capacitor. Right? That pretty much sums up the diagram. Equivalent capacitor is that single capacitor which can do the same thing as what this can do. Now, the derivation. So let's consider three capacitors connected in series and voltage across them is V. So this is V and this is your C1, C2, C3. So the voltage drop will be the same across all of them, right? Because they are in parallel. The charges though will not be the same. This can be Q1, this can be Q2 and this can be Q3. So voltage drop across each capacitor is same because they are connected in parallel. Therefore the capacitance, sorry, not capacitance, the capacitor has the same charge as they would if each were connected individually to the voltage source. They're not telling it's same with all of them. Q1 is not equal to Q2, may not be equal to Q3. They need not be equal. Of course, they can be equal, but they need not be. So that's the funda. So what can we do over here? Think about it. What is the basis over here? Yes, it is to do with charges, the total charges stored in the combination is given by Q is equal to Q1 plus Q2 plus Q3, right? So we know that C is equal to Q is equal to CV. So C is equal to, okay, no, I need to substitute this only, right? So we have CP V is equal to C1V plus C2V plus C3V, where CP is equivalent capacitor, right? Then what else? If I cancel V, so Cp is equal to C1 plus C2 plus C3, so on and so forth. A very simple result, right? So what does the result tell? The equivalent capacitor is larger than the largest individual capacitor because we are adding up. The charges on each capacitor may or may not be different and depends on its capacitance. The voltage will be the same though. The total energy stored in the capacitor is the sum of energy stored in each capacitor. Makes sense. Yeah, you guys can pause and have a look.